Hello, children. How are you all? Hope so. You are doing good. Welcome to one more session on competency focused questions. In the previous sessions, we solved the question number 1 to 60. In the today's session, we are going to solve from question number 61 onwards. So before that, do not forget to subscribe my channel. That is Ignite Math ARP if you have not yet subscribed. And don't forget to hit the bell icon. Now let me take the question number 61. In the question number 61, they have given you a triangle ABC and you are supposed to identify the coordinates of ABC, and later you are supposed to reflect those points in the origin. So before we reflect the points in the origin, let me identify the coordinates of the point A. So coordinate of the point A is 4 comma 5. So coordinates of the point B is 0 comma 3 because it is on y-axis, and the coordinate of point C is 3 comma 0. So now you are asked to reflect the point A in the origin. When it is reflected in the origin, the sign of the coordinates will get reversed. So it will be like -4, -5. When the point B is reflected in the origin, it becomes 0 comma -3, and when the point C is reflected in the origin, right, so then it becomes -3 comma 0, and you're asked to find out the invariant points on reflecting the triangle ABC on the x-axis and y-axis. That is your question B. So now invariant points, you must know what are invariant points. Invariant points are those whose reflection remains same as the original point, right? So invariant points, when it is reflected on x-axis, is equal to, it is a 3 comma 0. Every point on the x-axis is invariant in x-axis. So I can say point A is invariant in x-axis, and invariant point on y-axis is the point B, whose coordinates are 0 comma 3. That is, point B is invariant in the y-axis. Now let me take the next question. Determine the ratio in which the line y equal to 2 plus 3x divides the line segment joining A, B. The coordinates of A and B are known to you. So over here, the point A is there, -3 comma 9, and B over here is 4 comma 2. The line y equal to 2 plus 3x divides the join of the points A, B in a particular ratio. I will take the ratio as M1 and M2, and I'll take this point as P. So this line y is equal to 2 plus 3x is passing through the point P. So now what can I write? By section formula, the coordinates of point P is given by m1 x2 plus m2 x1 by m1 plus m2, then m1 y2 plus m2 y1 by m1 plus m2. You can take the ratio as k is to 1 also, children. So now here I will do the substitution, m1 x2. So here I just call these points as x1 y1, and over here x2 y2. So m1 x2 in the sense 4m1 plus of m2 x1, that is -3 m2 by m1 plus m2. Later m1 y2 is 2, so 2 m1 plus m2 y1 plus of 9 m2 by m1 plus m2. So since the point P lies on line y is equal to 2 plus 3x. So in the place of y, I'll substitute the coordinate of the y here, and in the place of x, I'll substitute the coordinate of x. So that becomes 2m1 plus 9m2 by m1 plus m2 is equal to 2 plus 3 into x. X is 4m1 minus 3m2 by m1 plus m2. So I'll keep this as it is, 2m1 plus 9m2 by m1 plus m2 is equal to, here if I take LCM, this is going to be 2m1 plus 2m2 plus of 12m1 minus of 9m2 divided by m1 plus m2. So m1, m2, m1, m2 get cancelled. I'll be left with 2m1 plus 9m2 is equal to, here m1 and m1 can be added, 14m1, okay, minus 9 plus 2 minus 7m2. So now I'll bring all the m1 one side. So 14 m1 minus 2 m1, then 9 m2 plus 7 m2. So 9 plus 7 is 16 m2 is equal to 12 m1. So I can write m1 by m2 is equal to 16 by 12. So that is equal to 4 by 3. So required ratio m1 is to m2 is equal to 4 is to 3. So I can write the conclusion as a required ratio is equal to 4 is to 3. So now let me take the next question, children. The square ABCD lies in the third quadrant of XY plane. So I will roughly draw a x-axis and a y-axis over here just to make you understand. So now look at this. This is -1, -2, -3, -4, and over here it is -1, -2, -3, and -4. The point A is at the vertex -3, -1. -3, -1 would come over here. This is A. Diagonal BD produced is equally inclined to both the axes, and the diagonal AC BD meet at -2, -2. So -2, -2 in the sense it's over here. This is the point of intersection of the diagonals. So means what? AC should be somewhere over here. BD should be somewhere over here. So this is our required square ABCD. ABCD. So because BD produced is equally inclined means what? This is equal to each other. So equally inclined in the sense that it is making a 45-degree with the both the axes. So now here if this is 45, this is also becomes 45. So I can say that theta for the diagonal BD is equal to 45. Inclination of the diagonal BD is equal to 45. Therefore slope of BD is equal to m1 is equal to tan theta. So tan of 45-degree, so that is equal to 1. So later what you are asked to find out? You have found out the slope of BD, that is our first sub question. So later you are asked to find out the equation of AC. So you know that ABCD is a square. So since ABCD is a square, AC is perpendicular to BD. So if two lines are perpendicular to each other, product of their slopes is equal to -1. This is what we learned in a equation of the line. So slope of AC into slope of BD. So slope of BD, I'll just take it as m1. Slope of BD into slope of AC is equal to -1. So I know slope of BD is 1 into m2 is equal to -1. So I get m2 is equal to -1. So now by point slope form, equation of AC is given by y minus y1 is equal to m of x minus x1. So y minus of, we know that this point is point of intersection of AC and BD. So means what? This -2 comma -2 lies on AC as well. So I'll consider that point itself. Y minus of -2 is equal to m is how much? -1, x minus of -2. So y plus 2 is equal to minus x, then it becomes -2, because minus x plus 2 into -1 is minus x minus 2. So when I take this x this side, x plus 1 plus 2 plus 2 equal to 0. So x plus 1, x plus y plus 4 is equal to 0. So this becomes the equation of AC. This is my final answer. Children, do not forget to write each and every step clearly, since it is a subjective type questions. Okay, distribution of marks will happen according to the steps whatever you have written. Now let's move to the next question. Question number 64. ABCD is a rectangle. If it is a rectangle, I know that each angle of a rectangle is 90 degree, and they have given you that ACQ is similar to BAQ. So now triangle ACQ is similar to triangle BAQ. If ACQ is similar to BAQ, we know that the ratio of their corresponding sides are equal to each other. Means what? The corresponding sides are proportional to each other. So I can write AC by BA is equal to CQ by AQ is equal to CQ by AQ, sorry, CQ by AP. All right, this is BAP, children. This is BAP. So CQ by AP is equal to AQ by BP. Okay, so how do you decide it? So like first two by, look at this, first two letter by first two letter, in the sense AC by AB, then CQ by AP, CQ by AP, then AQ by BP, AQ by BP. Right, so you are asked to find out what? You are asked to find out the ratio of the areas of BAP and ACQ. Clear, children? So for that, I know one of the theorem that if two triangles are similar to each other, the ratio of their areas is equal to the ratio of their areas is equal to the ratio of squares of their corresponding sides. So now what can I write? So area of triangle BAP by area of triangle ACQ is equal to what can I write down? BAP, in the sense of BAP is this triangle I'm supposed to take. ACQ is this bigger triangle. So what I do here is I'll write this one as a AB square divided by AC square. But one more data is given to you. Here it is given that BC is twice of AB. So if I'm taking AB as x, BC is going to be 2x. So now I have to bring in AC in the picture. So in triangle ABC, angle B is equal to 90 degree. So I can write AC square is equal to AB square plus BC square. This is by Pythagoras theorem. So I can write AB square. AB square is what, children? X square plus BC square, that is 2x the whole square. So that is equal to x square plus 4x square I get. So that is 5x square I get it as a AC square. So now AB square is what? X square, and AC square is what? 5x square. So when I cancel x square and x square, I get it as 1 by 5. So what can I write? Area of triangle BAP is to area of triangle ACQ is equal to 1:5. Here you must be aware of what is the theorem, children. Okay, application of the theorem is important. If you don't know the theorem, you cannot apply. Let us move to the next question. So next question is, see here again, it's a geometry question. They are given that D is a point on BC such that BD is equal to 4 centimeter, DC is equal to x centimeter, and BAD is equal to C. BAD, this angle is equal to C they have given you. So prove that ABD is similar to triangle CBA. So now I'll take up the first question. Triangle ABD. So ABD and triangle CBA. So if you observe carefully, B is the common angle. So I can write angle ABD is equal to CBA, since angle B is a common angle. Then later, here it is given to you that this angle is equal to this angle. So I need to take the use of that. So what can I write over here? Angle BAD is equal to BCA. Okay, so that is given to you. Okay, BAD is equal to BCA. So therefore triangle ABD is similar to triangle CBA, right? So by angle similarity, angle also you can write. So once you know that they are similar to each other, now I can write down the corresponding sides. That is, I told you first two by first two, right? So that is AB by CB is equal to BD by BA is equal to AD by CA. So wherever, whichever is known to you, you can take. So AB is known to you. Yes, it is known to you. 8. CB is known to you. Yes, it is 4 plus X is equal to BD. Do you know BD? Yes, I know it, 4. And BA, I know it as 8. So these two are sufficient to find out the value of X. So what I do here is I'll cross multiply. 8 into 8 is equal to 4 into 4 plus X. Or you can just retain this 4 over there, no issues. So 8 into 8 divided by 4 is equal to 4 plus X. So 1 za, then 2 za, 16 minus 4 is equal to X. X is equal to 12 centimeter is my answer. Is that clear, children? X is equal to 12 centimeter is the option, I mean correct answer. So now let's move to the next question. In the extract of survey of India map G43S7 prepared on a scale of 2 centimeter to 1 kilometer. So means what, children? First of all, I need to find out the scale factor. Okay. So child finds the length of the cart track between two settlements is 7.6 centimeter. So let me find out the scale factor over here. Scale factor, to find out the scale factor K, I need to take the model, that is I can say it is a 2 centimeter to 1 kilometer, 2 centimeter to 1 kilometer. So I will express this kilometer in terms of centimeter. You know that 1000 meters makes 1 kilometer and 100 centimeters makes 1 meter. So I can write this one as 1 followed by 5 zeros. Okay, so which can be later reduced to 1 by 5 followed by 4 zeros. Clear, children? Right. So that is nothing but 1 by 50,000. 1 is to 50,000 is the scale factor. So now what is the first question? A child finds the length of the car track between two settlements is 7.6 centimeter. Find the actual length of the car track on the ground. So first one, I'll just take it as a length on the map. Okay. So length on the map is equal to K into actual length. K into actual length. So now length on the map is what? It is given to you as a 7.6 centimeter is equal to K into, K is what? I can write K over here. Since I know what is K, I can directly write down K over here, children. So I will replace K. Let's not increase one more step over here. Here itself I will write K as a 1 by 50,000 into actual length. I'm supposed to find out the actual length. So I can say the actual length is equal to 7.6 into 50,000. Clear, children? So 7.6 into 50,000, I'll be getting this one as a 38 followed by 4 zeros. Clear, children? 38 followed by 4 zeros, that is that much centimeter. So this much meter and meter, so I can say it is 3.8 kilometer. 3.8 kilometer. So later actual area of the grid square, if each has an area of 4 centimeter square. So know that you must know that whenever I'm talking about the area, it is k square time of x area of the model is equal to k square time of the actual area. When it comes to volume, it is k cube times. So I can write area of the model. I can write area of model is equal to k square time of actual area. Okay, actual area. So now what can I write? So here it is given to you that the area of the model is 4 centimeters square. So 4 is equal to 1 by 5 into 10 to the power of 4 square into actual area. Okay, so what I have written? I have written 50,000 as 5 into 10 to the power of 4. So this becomes 4 is equal to 1 by 25 into 10 to the power of 8 into actual area. Okay, so what can I write for actual area here, children? So actual area is equal to actual area of the grid is equal to 4 into 25 into 10 to the power of 8 centimeter square. So that is nothing but 100 I get over here, 10 to the power of 8 centimeter square. So that is nothing but 10 to the power of 10 centimeter square. So you know that, children, this conversion you must know that 1 kilometer is equal to 1, 2, 3, 4, 5 centimeter square. Okay, means what? 10 to the power of 5 centimeter. Okay, 10 to the power of 5 centimeter. So 1 kilometer square is equal to 10 to the power of 5 into 2 centimeter square. So means what? 10 to the power of 10. So I can write this one as a 1 kilometer square. Okay, so that is going to be actual area of the grid. Clear, children? I can write this one as 1 kilometer square. So now let's proceed with the next question. Construct a triangle ABC where AB is equal to 7 centimeter. So here roughly I will draw it. Please, you can try with the compass and the other geometric instrument, children. AB is equal to 7 centimeter. BC is 6 centimeter. So now BC in the scale, I will take BC as 6 centimeter with help of compass. I will draw 6 centimeter over here. And from A, I'll take 5 centimeter in the compass and I'll cut it off. That is going to be C. So this I will join, that is AC and BC is joined. So draw a locus of the point such that it is equidistant from BC and BA. BC and BA. You must know, children, whenever the locus of a point you are going to draw which is equidistant from two lines. So means what? It should lie on the angular bisector of that angle made by that particular line. So what I do here, I will draw the angular bisector of angle ABC. To draw that, I'll keep the sharp edge on B and draw one arc and keep the sharp edge of compass over here, draw one more arc over here like this. So this will be the angular bisector of B. So the required locus of the point lies on anywhere this point BE, I can say. It is lying on anywhere on the line BE. Then it is equidistant from the points A and B. So equidistant from the A and B. Whenever you are drawing the locus of a point which is equidistant from two fixed point, then you have to draw the perpendicular bisector of the line joining that 2 points. So keeping the sharp edge at A, taking more than half of A, AB, I'll draw one arc up and one arc down, and don't change the length of the compass, keep the sharp edge at B and cut these arcs. So now what I get is a perpendicular bisector of AB. The required point lies anywhere on this line. I can call this point as XY. So it lies on anywhere. So now mark P where the loci 1 and 2 meet. Measure the length of PA. So this point is our P and you are supposed to measure PA is how much. So PA is how much approximately. When I do it literally, I'll get it around 3.7 or 3.8 centimeter. Clear, children? So this will be the right answer for 67th question. So now let's move to the next question. In the given figure, O is the center of the circle, ABC, it is a quadrilateral where sides AB, BC, CD, DA touch the circle at point E, F, G, H respectively. AB is equal to 15 centimeter. So the length of the side AB is given to you as 15 centimeter. BC is given to you. This is BC, which is given to you as 18 centimeter. Then AD is given to you as a 24 centimeter. Clear? So you are supposed to find out the length of CD. CD is how much is the question. So now I'll just take the length of the line segment DG as X. Okay, X. And you know one of the theorem, children, in the circle lesson, whenever a tangent is drawn from the external point to the circle, the tangents are equal in length. So these two tangents are equal in length. Clear, children? So if DG is the tangent drawn from the external point D to the circle, then DG should be equal to DH. So this should also be H. So I can write DG is equal to DH. What is the reason you are giving? You are giving the reason as a tangents drawn from the external point to circle are equal in length. Equal in length. You are supposed to give the reason anywhere. Okay, at least once you are to give. So now this becomes X, this also becomes X. So now this total is 24. So this becomes 24 minus X, children. If this is 24, AH is equal to AE. So this also becomes 24 minus X. Then EB will be what? EB will be 15 minus of 24 minus X. So in the sense 15 minus of 24 plus X. So the X minus of, I'll get it as 9. So EB will be X minus 9. If EB is X minus 9, then I'll get FB also X minus 9. So then FC will be what, children? It is 18 minus of X minus 9, that is 18 minus plus 9. So I'll get it as 27 minus X. What? CF. If CF is 27 minus X, then GC will be 27 minus X. Clear, children? So now I'm supposed to find out the length of DC. DC will be equal to DG plus GC. DG is how much? It is X plus of GC is how much? 27 minus X. So that is equal to 27 centimeter. DC is equal to 27 centimeter I am going to get. Clear, children? So now let's move to the next question. In the given diagram ABCD, in the given diagram ABCD, ABCD is a regular hexagon. You are supposed to find out FAG. So hexagon is inscribed in a circle, children. Okay, so now you know that to find out FAG is nothing but exterior angle of a regular hexagon. So you know that exterior angle of a regular hexagon, okay, is given by 360 divided by n. N is 6 over here. So you'll get it as 60 degree. So angle FAG is equal to 60 degree. Clear, children? So next, second one is what? BCD. 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 It is nothing but interior angle. So interior angle of the regular hexagon is equal to how much? If exterior angle is 60 degree, exterior angle plus interior angle is equal to 180 degree. So each interior angle becomes 120 degree. So now third question, if you observe carefully, PDE. PDE. So this is angle, that is alternate segment. If I use alternate segment theorem, this angle would be equal to this angle. So this angle is already known to you, that is each interior angle of a regular hexagon, that is 120 degrees. Since it is a regular hexagon, this side is equal to this side. So I can say angle PDE is equal to angle EFD, that is a alternate segment theorem. Then EFD is how much? It is going to be 120, that is 180 minus 120 divided by 2. 60 divided by 2, that is 30 degree. So I can write that PDE is equal to 30 degree. So now let me take the last question over here. AB and CD intersect each other at O of a circle given in the above diagram. EBA is 33 degree and EAC is 80 degree. degree. BAE you are supposed to find out. BAE. BAE. Right. So BAE is this one. So you know that this is the angle in the semicircle 90 degree. So this angle is going to be 90 plus 33 plus this angle is equal to 180 degree, children. So how much will be this angle? You must know that angle BADE will be 57 degree. So this is going to be 57 degree. So answer for this is 57 degree. Then BOC. BOC. How much is this angle? BOC. Can you tell me how much is this angle, children? See, this total angle is 57. 57 to be subtracted from 82. If I subtract 57 from 82, I will get it as 25. So this angle is going to be 25. This angle is formed at the center. This will be 50 degree because it is twice of that. So now if this is 50 degree, this is going to be 130 degree linear pair. This angle and this angle form linear pair. So 130 plus 33, 163. So this angle will be equal to 180 minus 163, that is 17 degree. So this angle is going to be 17 degree. Angle ODB is equal to 17 degree. Clear, children? I hope so. You have understood. Is the solution clear to you? Yes. In the next class, I'll take the question number 71 onwards. Till then, take care. Keep working. Bye-bye.